Coming up on This Week in Radio Tech, we're remembering an amazing engineer, an amazing man, father, colleague, and friend, and that's John Lyons. We have Chris Tobin here, who worked with John Lyons for 27 years, and Tom Ray is going to make a guest cameo appearance on the show right at the beginning of the show, so you want to watch that. It's all coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, the weekly show where we talk about everything from the microphone to the light bulb at the top of the tower. I'm Kirk Harnack, your host, here in the Nashville TELOS Alliance studios. I appreciate my employer, the TELOS Alliance, for giving me a little bit of time and some equipment to carry out this broadcast, this show, this webcast of This Week in Radio Tech. We've been doing this for just about 10 years now. Actually, we have been doing it for 10 years. We skipped a summer, but other than that, we doing this for 10 years. This is episode 472. And I'm just delighted to be with you. Just to let you know, if you're not familiar with the show, I do work for the TELOS Alliance. I have been working there for almost 20 years. And I do technical work and sales work and marketing work and, trying to fit round pegs into square holes, that kind of work at the TELOS Alliance. Good storyteller, too. I like to tell people I'm enthused about a lot of the technologies there. Also, I'm part owner of some radio stations, 14 radio stations in all. I own the part that doesn't make any money, which is why I work for TELOS full-time. But it does give me an opportunity to keep my hands dirty with broadcasting technology. And so there you go. Once in a while, I do the weather on the NBC affiliate here in Nashville when they're really desperate. It's been a while. All right. Hey, my co-host is here, and that is Chris Tobin. Hello, Chris. Welcome in.
Well, hello, Kirk. I'm just here in our performance space. And a little quick ad hoc. The lights are not in the place that I like them, but it is what it is.
It's okay. We're actually, most of our show is going to be some video that we pre-recorded, but we've got some things to talk about, and we'll get to that in just a second. I want to bring in our special guest, former co-host. He was able to join us again, and that is Tom Ray. Tom, unmute and say hi. How you doing?
Hey, Kirk, how you doing? Everything's great. I apologize for the video. My usual lighting technician's on vacation. Actually, I'm sitting in the car at a rest stop in Roscoe, New York. Now, before you laugh at Roscoe, New York, it's the trout fishing capital of the world. So,
I'm sorry, it's the what capital?
The trout fishing capital of the world.
Oh, wow. I didn't know that. All right.
It's also known for the Roscoe Diners.
Today.
If I ever have time to retire from my job, I want to go trout fishing with you. Or at least you can carry me to Roscoe anyway.
Works for me. They got a great diner, like Chris said.
Wow. Hey, well, guys, we're going to get a little bit of business out of the way. Our topic today is remembering a very special and amazing engineer named John Lyons. John is an absolute stalwart of the RF scene, radio and television scene in New York City. And I had the pleasure of meeting John a couple of times, actually 4 or 5 times, but Chris Tobin and Tom Ray will have a few things to say about John Lyons. And then we're going to review, we're going to look at a presentation that John Lyons made a couple of years ago about the new One World Trade Center and the rooftop, the antenna facilities there, and just how they got done some amazing tasks using technology from literally all around the world. That some of it came in by boat, some by airplane. A lot of it got lifted, up the side of the building. Just amazing stuff. If you haven't seen this presentation, my friend Ed Bucont says you don't want to miss it, and I believe Ed. Our show This Week in Radio Tech is made possible sometimes by my friends at Josh Bone at Max Connect Wireless. And what's special about this? It looks like a Cradle Point router because it is, but it's really special because of the SIM cards that are in here. There's 2 in here. One's on AT&T, one's on Verizon. And the data service that you get from Max Connect Wireless is special because you have priority over almost everybody else, kind of everybody but first responders. And that means that if you're at a live broadcast of some kind, a ball game, you're in the press box, you're doing a live broadcast from a tailgate party out in the parking lot, you're covering live news coverage from somewhere, you're at a parade, car dealership, whatever. You bring this box with you, you turn it on. Within a couple of minutes, it is solidly connected to the wireless network of your choice, either AT&T or Verizon, and you have priority data. Now, the data rate, for example, that I'm getting, I get 5 megabits per second up and down with this Max Connect wireless. Doesn't sound like a lot, but you know what? Every packet gets through. Very few, if any, lost packets. And it's just absolutely terrific for broadcasters. You can run video through this, as we do, IP video. And of course, you can run audio through it as well. Chris Tobin and I have done numerous shows with the Max Connect service. Check them on the web. It's maxconnectwireless.com. Of course, it's spelled funny because all the good names are taken, but MAXXKONNECT wireless.com. And you'll find it there. Look at our show notes if you can't remember that, because we put that in the show notes every single show. And my hat's off to Josh Bone, engineer, broadcast engineer from Alabama, and he has worked tirelessly to make this service possible, and by golly, it works. Our show is also brought to you in part by Angry Audio. By the way, we're doing a couple commercials early here so that we can enjoy John Lyons' presentation with only a couple of quick interruptions there. My friends at Angry Audio, you familiar with Studio Hub? If you're not, you ought to be, and if you are, you're glad that it's not gone, because, you know, there were rumors a few months ago that Studio Hub was gone. Well, that's not true. My friends at Angry Audio have as far as I know, the entire line of cables and adapters in stock, and they're making more cables, same factory, same employees, same jigs, same everything with the Studio Hub. And this is good stuff, well made. I tell you what, they've really figured out the right way to get audio cables to go into RJ45 connectors. And on the other end, of course, you can get, you know, XLRs or 1/4-inch tip ring sleeves, all that kind of stuff. And they have this is one that, well, there you go on screen there. You see all the female RJ45s going out to either male or female audio connectors. They also have the kind where, if you scroll down a bit, I think you'll see them. There you go, where you have the male RJ45 connector on one end. And these are typically 6-foot cables, and they'll go to whatever professional audio connectors you want at the other end. Now, with the female adapters, right now, if you place an order and ask for it, you get a free patch cord with every one of the adapter cables that has the female RJ45 on it. You don't need it with the male ones. They're 6 foot long anyway. But of course, you can use whatever cable length you want. You know, 200 feet, 100 feet, 2 feet, 1 foot, 6 foot. You can actually, these are, I think, 5 feet. But anyway, you get these free, one of these free with every adapter from angryaudio.com. Go to angryaudio.com and check out the full line, and then talk to your dealer about getting Studio Hub adapters. I wouldn't settle for anything else. These are the bee's knees, the cat's meow. They just work. Thanks, angryaudio.com, for sponsoring This Week in Radio Tech. All right, gentlemen, we have an opportunity here to take just a few minutes to talk about John Lyons. Now, he passed away not long ago. I want to say it was in November. I had it up here just a second
Day
ago.
after Thanksgiving.
That's right. It was November 29th, 2019. John was born in 1948. So you do the math. I guess he was about 71 years old or so when he passed. Still very active in engineering and loved by all. Tell you what, as long as we've got Tom on the line here, and before anything happens to his connection, Tom, I think you have a wonderful little remembrance about meeting John Lyons for the first time. What happened?
Yeah. As a matter of fact, when I first started at WOR in 1997, everybody at the station just told me, you got to go meet John Lyons. You got to go meet John Lyons. And okay, I'll go meet John Lyons. So they arranged a lunch, and I went out with John Lyons, and John had worked at WOR. And, you know, we met, we shook hands, we sat down, and he looked me up and down and looked me in the eye and said, it's nice to see that they insist that the WOR engineers go to the same barber I used when I
It's John's humor. That's John's humor.
Yeah, and from that point on, I knew, you know, there wouldn't be an issue between us, and actually that was true. I mean, the guy was great. He, you know, when he first built 4 Times Square, he had given me a call. You got to come up and see it. You got to come up and see it. I went up and saw it. It was fantastic. Then he modified 4 Times Square. You know, because originally it was for the Clear Channel stations that were there, and then he was working for the Durst organization and developed 4 Times Square as a viable backup site for many of the New York City broadcasters. So we went up and saw that. He was really proud of the fact that, you know, for RFR radiation compliance, he had this little light system, and I forget exactly who made the system, but it was a 5 light system. But there was nothing on the box. When you looked at it, there was no way to tell what the lights meant. So you pushed the button, and he was really, really, really proud of the fact that he got Valerie Smaldone from Light Night 1067 to record all the bits. So if the red light was on, you hit the button, it told you can't go out on the roof. The antenna's on the air. If the yellow light was on, she came up and told you where you could and could not go. And yeah, for 2000, that was quite ingenious. And when we moved WOR, I needed a space for an STL repeater because I couldn't make the shot from the building we were at. 950 doesn't happen to like going through buildings. So I went up to 4 Times Square and said, John, what can we do here? And Rick Buckley, God rest his soul, he said to me, my God, what's that going to cost? This is New York City. I said, let's see what John does. He came back with a more than fair price. I mean, I was shocked. Basically gave me the run of the castle, whatever I needed, whatever I wanted. When I left WOR, as a matter of fact, it's in my pocket right now. I've still got a card key for 4 Times Square. I called him up. We went out for lunch. I handed him the card key. He says, what are you doing? I said, I'm giving you my card key. I'm not going to be at WOR starting next week. And he said, no, you hang on to it. He says, first of all, you don't know if you're going to need it. He says, second of all, he says, you're somebody I can call if I'm out of town and there's an issue up here because you'll be able to figure it out. He says, please keep the card key. So I did. And then, of course, he built One World Trade Center and, was on the phone to me like every 2 weeks. You got to come up and see it. You got to come up and see it. You got to come up and see it. Well, eventually I had a client who might have been interested in renting space up there. So I called John and said, can we bring the client up? He goes, yeah, come on up. So we went up. That was the day. The building was still under construction. The mast was on the building. And that was the day they had just put the low-rise elevators into service. And, we got in the elevator and he said to me, he says, just be aware, we may be here for a while if it malfunctions. Yeah, okay, whatever. We went from ground floor to 64 in under 60 seconds. Didn't even feel the thing move. Then we got out and had to take these rickety elevators up. And I mean, to stand on the roof of One World Trade and look up that mast was incredible. It really was. I mean, that's quite the engineering feat that done. And one of the things John specialized in, as people watching, probably figure, in New York City, it's a union town. And the unions are quite adamant, they don't step on each other's toes. And John was really good about, getting them to work together so there wouldn't be any conflicts. And the story he liked to tell was at 4 Times Square when they put when they were going to put the new mast up. It was sitting on the street. They're all ready to do the pick. And people realized, well, wait a minute, the beacon's not on the mast. It has to get on. So the electricians start working on it, and this thing's, I guess, Chris can correct me, it's something like 400 feet long. So, we're talking a 400-foot run of cable. And they start pushing the thing in, and they're having trouble. And the electrician's like, well, we got to go get our cable pulling lube, and that's in the truck. It's parked 3 blocks away or whatever. And John's like, we don't have time for this, guys. Come on, we're paying for a crane. He looks around, and there's a food cart. What are they selling? Bagels. Besides cream cheese, what do you put on bagels? Butter. Butter's a lubricant. He bought 7 bagels with butter, handed them to the electricians. They looked at him and they said, we're not ready for lunch or breakfast. And he said, no, use the butter to grease the cable. They grabbed the thing and, run the cable through the bagel and got it through the conduit. That's the kind of guy John was. And,
run the cable
very
through the bagel. Oh, my gosh.
Yeah, I'm going to miss the guy. He was just a great guy.
Tom, thank you for those stories. I don't mean to cut you off, but we're gonna move on to the rest of the show. Thank you so much for taking the time to join us and share your experiences with John Lyons. It's a real blessing to hear those stories. Thank you.
Well, Kirk, thanks for having me, and this is good. My wife won't get upset now. I won't be late for supper.
Well, hang on if you like. Just mute your mic.
Okay. Have a great night.
Okay. Okay. Thanks. All right, Chris
Bye-bye.
Tobin. Wow. I'm sure you have some stories to tell too, Chris. Is there anything you'd like to open up with before we start the presentation? And that's the system that Tom was talking about.
That is the system as of 2 days ago. It still exists. And the box on the right, the black button is just for information purposes. The bottom on the red is if there's an emergency, it will call down to the security. On the left side, you see the lights. They're green, amber, red. On some levels, there are actually blue and white for the TV signals, but this particular door is at the lower roof, so it only requires those three. And yes, all the lights are green typically, except for when there's a high power FM's working on the backup antenna, or if the TV folks are online. So that's what it looks like. And down below is the paperwork for the RFR information, and in the middle, the paperwork in the middle is the actual diagram of the rooftop superstructure, so you know where you are as to which spots you can enter and exit, and which is safe and which is not. All there. Every entrance and exit on the rooftop has this system.
Wow. And that tells me
and
that
it's also in the combiner room.
That tells me that John didn't just care about following the law; he cared about people, and he wanted to do everything he could so that a person would not get hurt or wouldn't themselves break the law, break rules and regulations about work situations.
Yeah, no, that was John did. Every time you drive, you see the Manhattan Skyline. There are two spires that you can say you watch the guy who built it. He was the project manager on both 4 Times Square, now known as 151 West 42nd Street, and 1 World Trade Center. Those are 2 biggies. He's also done other work. Matter of fact, in New York City, back in 2009, I think it was. Oh, hopefully I got that right. 2008, the first responder communication system went in 9 buildings by the summer of 2008 or 2009. The Durst organization had, and that was on the news. It's nothing secret. This is all public knowledge, and he was part of the team that put that together. So in the high-rise buildings, at least the Durst, and now several others, fire department, police, and EMS can run between the building floors and stay in communication with the incident command center down at the lobby. There's video of that too, and he was instrumental in working with the communications folks at FDNY and NYPD to put that together. So that's the other part of what he did. Again, the people side. That was the people side. But yes, anyone who's worked with John Lyons knows he can be a very sarcastic, witty, giving person. As long as you understood that and you responded in kind, you had no problems, and he would take care of you. And to the story of the key card with Tom is very true. I still have my key card from before I was there for BGO. I was there early on, and he just said, keep it. You'll never know when you may need it, or I may need to call you. And I can assure you I got called plenty of times, and he would make it a point to put me on the roster for RFR training and yearly, and also rigging safety. So I have all that stuff under my belt. So it's he was good. He knew his stuff. He was a fun guy.
Tell you what, without further ado, we do have a presentation that John made. This will, we're talking about John, but let's actually hear from John. If you haven't seen this, oh my goodness, it's so informative, so helpful, and I was able to edit John's actual slides into this, so you won't be, trying to look at a fuzzy TV screen. We'll put the actual slides up that John's talking about. So if our producer Suncast is ready, let's go ahead and roll this. The first voice you're going to hear is David Bialik with a short introduction of John Lyons, and we're going to have limited commercial interruptions here on this just a couple of times. So watch, enjoy, stay tuned throughout.
Now, I want to introduce John Lyons, who I've known for many, many, many years, from the time he was at WRKS, and I've known him through his career. We've worked at some places together. We've worked at a lot of places apart. John has the unique reputation. When I first met him, he was the chairman of the Empire State Building Master Antenna Committee. So he had something to do with the master antenna planning back then. He has built 4 Times Square twice, and he has now built 1 World Trade Center. So he has really changed the face of FM and TV broadcasting in New York City, and has now built the highest broadcast facility in the United States. John?
Okay, first, thanks everybody for coming. And as I go through this, I'm going to sit down. I injured my foot, so standing is a little difficult, and it's starting to bother me at this point. So hopefully you can hear me. The only noise coming from the floor right now are the fans in the server rack over there, which unfortunately I can't turn off. Before I begin, you are sitting next to a live TV transmitter. The transmitter is putting 67 kilowatts out right now, WNJU on channel 36. So that is live. It's a water-cooled transmitter, hence there's not a lot of noise coming out of it, unlike the old air-cooled days of all of us who worked in broadcasting for years and are used to 115 dB of noise coming out of a fan of a transmitter. So we did it over here rather than in the other part of the floor. We are under construction, as you can see, and you'll see that when we tour later on. But this one is live. The combiner at the other end of the floor is live. So don't be touching anything that you could possibly turn off. I think WNJU would be very upset if I shut them down at the moment. CBS is this space here. All this cabling was put in today. This is not live. This stuff you can touch. It has not been connected yet. Richard Mullen is here from CBS. He can answer any questions about their facility. He was nice enough to come in late tonight and be with us to help tour around. So any questions? Chris Tobin, who's walking around with the mic, is also somewhat familiar with the facility. He's there doing some work for me on GPS, et cetera, in the building. So we do have a couple of other people you can ask questions as we walk around. So to begin, very quickly, and I am going to sit, hopefully you can hear me. And Kirk, if you need to readjust the camera, I'm sitting down here. The little history of the building. These slides, some of them are courtesy of Alan Reese from the Port Authority and also Doug Long of WNJU from the original facility. So they're not, the historical stuff is not in any specific order other than lifting up a 20-yard container to the rooftop in the first shot here. So this is just some of the antennas that were up there, just to let you know what was there before and what we're adding now. Just different pieces of the spire going up from the rooftop, which was an elevated rooftop. All of the antennas in the left-hand photo. On the bottom there are two-way radio antennas. On the new facility, we have 3 rings wrapping around the top of the building that those antennas are on, as opposed to being on the flat deck of the building. Again, just different sections of the superstructure being put up as it was built, lifting it from the street. The sections today were lifted the same way from the street with tower derricks and brought up to the rooftop and then set. And the top then and the top now look a little different. Just a bow tie antenna at that time for the VHF channel 4 and 5, and the rest are the panels for the UHF antennas, and the FM was in the middle. There's your high anxiety shot looking down from the top. As you can see, as I said earlier, the two-way radio antennas are all here on the roof. This was a CNN ENG dish that I actually put in way back when. But this is what it looked like then. Tower 2 is over here, and if you are walking around the Memorial Park where the two pools are, those were the actual footprints of Tower 1 and Tower 2. So we are just north of the original Tower 1 over in this area now. And that's a picture you probably won't see today of any riggers walking around in a tree climbing belt, not secured to anything, smoking a cigarette, and just hanging outside the building, basically. That's the rules have changed a little bit in the last 40 years. These I took right about 9 months before that day, 16 years ago. The ENG antennas and stuff wrapped the bottom of the spire, and the standby antennas were low. Standby antennas were low, the FM was in the middle, and the primary antennas were up on the top. The ENG and the two-way and the point-to-point microwave were all wrapped around the middle. All of this ancillary service now is on the 3 rings, so if you look at the building from outside, you'll see those 3 rings. Unfortunately, with it being dark and late, and there is construction on the roof, we can't go up there, but you look at the pictures and you go, okay, fine, that's nice. You've got these 3 little rings. Well, those 3 little rings are 750 tons of steel. Sitting there on top of a rooftop of a building. So yes, the building, but still a building. And the new spire itself is 781 tons, also sitting on the rooftop of a building. So just put that in perspective when you look from the ground as to what you're seeing. And that's what was left of the area, about 120 foot up the tower after what happened. That was the hatchway. This was the RF safety shield, and that's what you climb through, getting up into the apertures. So, getting started down here, the tower sections, the bottom 9 sections were shipped from Canada by barge down the Erie Canal and down into the Hudson River. They were then brought over by barge to the building. The top sections came by truck, and they were brought to the site. This is the property manager of One World Trade Center and myself on the barge in the laydown yard when they first arrived. Here they are coming across the river as they pass the Statue of Liberty for New Jersey, where they were anchored, and then subsequently coming towards the building. So hopefully I'm not blocking you over here. As I said, these were brought up in pieces, one at a time, to the top, and then brought up and anchored. The upper sections were married, 2 sections on the ground, and then hoisted in pairs because they were obviously considerably lighter than the lower sections, and they could handle picking them up. If my memory is correct, the 2 tower derricks were 120-ton capacity each, so they had a good lifting capability to lift this stuff to the rooftop. Top section, they put the flag on. If you're looking now at the top section, the prism section is still live. This is still there. This crow's nest has been removed. The top UHF antenna actually goes up to just about here. So we had to remove this section to put it in to get the top elements of that antenna in. And there's the top section going up with the immediate section below it there. All those pegs, those climbing ladder sections have all been removed. That's all antennas now, and the climbing ladder is integral to the antenna. It's there's about this wide compared to those 24-inch wide climbing cells. I put this in there because this guy was dealing with the tag line, keeping that aligned. And you'll notice all his coworkers standing around doing absolutely nothing. This poor guy was on that line for 1,368 feet till they got that section up to the rooftop before he let go of that line. So I have to honor him for that diligence in doing it. As we go up again, this ice shield, as I said, this crow's nest here has been removed. This one's been removed. These are lights that were put onto the structure before it was lifted, so it could all go up as a unit. And there we go as we're climbing the top. The building was still under construction when the section was finished up. That was brought up May of 2013, so it's almost 4.5 years ago now. This is perspective. I'm standing on this ice shield at this point. This one, as they were building it. These are the stations that are up there now. We've also now adding WWOR, and on this antenna we're going to have WNYW. The 2 Fox stations have now joined this group of stations. So this was as the antennas were going up. There's the first antenna panels going up on the UHF up here, and you can see in this shot the crow's nest is gone. So we laid this out because NJU and CBS are both very high power, so I'm spreading the load over the 2 antennas, and then the composite of the other stations balances them out. So I'm essentially putting out the same signal on the 2 UHF antennas, and the VHF is in the middle, which has Public Broadcasting Channel 13 on. These will be all changed. This is for future antennas. There's some later pictures that show a little bit more structure, but everything was lifted piecemeal. All these antenna panels were lifted one at a time. These were lifted as 2 by 3 foot panel sections to make up the 96 that are here. There's 40 panels here. There's 16 panels in the VHF. These are the 3 rings I was talking about on the top of the building, and they're about 250 tons apiece of steel that will have ENG, electronic news gathering antennas, 2-way radio antennas, microwave point-to-point antennas, beauty cameras for the television people who have the beauty camera shot in the back of their newscasts will all be on these rings. This one right here is actually a camera looking down the skin of the building, one of 2 that Legends, the observatory, has. They have an indoor area that's a glass floor that you can walk on, but it feels like you're outside because it's actually projecting that camera shot underneath your feet. So you're totally safe, but you have a big, about a 15-foot diameter circle you're standing on, and you're standing outside the building. This is in here just for some background. We did a test antenna in 2015 for the TV broadcasters. They wanted to see what the signal actually looked like from this building as opposed to what was coming from the Empire State Building. They wanted to be certain they didn't lose any coverage immediately in the near field area below the building, and they wanted to make sure that what they got going north above Empire was equal to or better than. So we actually put a single face of antenna panels up, a UHF and a VHF, on top of each other. And this was the mount where the pole sat. There were two of them because they wanted to have it looking at Manhattan Grid North, which is the avenues in Manhattan, for those of you not from here, is actually 29 degrees off true north, but that's called Manhattan Grid North. So they wanted to go up that, and they wanted to be able to go plus or minus 30 degrees and see what the coverage was, so they could effectuate what the coverage was going to be in the areas of concern. So we had the structural engineer design this gimbal mount, so the pole actually sat in there, and when they got it up there, they actually scored it every 15 degrees. So when the guys had to move it, all they had to do was go to the next notch, and they could land it, and they knew exactly where they were. And that's what it looked like from the other side. Just for a little background. There they are working on the first panels. As you can see there, it's a little bit warm up there. It's just the one section. This is the top antenna that was put up, the UHF, with a much oversized pole that was much heavier than what was needed, but they didn't know what they were going to be dealing with at the time. These are the two test antennas up in place. The VHF is down here and the UHF is up there. This is the VHF panels going up. And as I said, we could orient them plus or minus 15 degrees so they could see what the coverage was in the marketplace. The Metropolitan Television Alliance, the MTVA, for those of you who know them, did some measurements back about 5 years ago on a single frequency network, and they wanted to see what the coverage was, and they actually had a test transmitter at 4 Times Square on one system and a test transmitter on the Empire State Building on the other system. And they had all these points set up, GPS coordinated in their computer, and they could go out and measure those spots to see what the coverage was. Since they had that database, they reused that, and they added another 100 points to it to test down here. So they already had established what was coming off Empire State Building, what the single frequency network channels were projecting, and they could compare it to what was here. So this is mostly looking at Manhattan and northern Queens. This one is showing upper Manhattan, lower Westchester, and they knew they had a null from the Empire State Building along the Long Island Expressway, so they added all of these points out to the radial horizon to see just how much null fill they actually were able to get. This is an overview looking at the New Jersey area they covered and up and down into Brooklyn. Obviously, it's safe to say that the test was successful because 7 of the TV stations are now either on the air or building down here. Some of the things, great picture after traveling to Australia, 26 hours, that's what you look like. The antennas are all from RFS. That's Phil Sindrich from Myatt, Nick Wyman from RFS, and myself at the plant in Australia, getting ready to proof the antennas. Over the period of time, I made several trips over there to do that. This is what the UHF antenna panels look like inside. They're set at plus and minus 45 degrees to get an elliptical pattern, which essentially gives you a circular pattern when you're done. They're pre-calculated through the combiner to actually do the offset to bring them up to what the FCC would accept at 0 and 90, because these are plus or minus 45. That's what some of the panels look like in the assembly line. The radomes actually are manufactured for RFS in New Zealand and then shipped into Australia to be assembled. Power dividers. We bring up the lines, as you can see some of the transmission line over your head, and you'll see down at the combiner end, 2 8-inch lines, 2 7-inch lines, and 4 4-inch lines. The 8s and 7s feed the 2 UHF antennas, and the 4 4s feed the VHF antenna. But they then go up and they power divide down and down and down into smaller lines and essentially hit all the antenna panels in at 7 8-inch transmission lines. So going in case from 8 to 6 to 4 to 3 to 7 8, and any combinations depending on which antenna they're feeding. On the test range, we did a 2-section of antenna. They're 8 sections high. That's the PEP 40, the upper UHF, and you can see the integral ladders in it. And then the PEP 96 is 12 around. That's 5 around, 8 high. This is 12 around, 8 high. And again, you can see the ladder sections being built into the antenna. So all of those climbing pegs and everything that was put on the building had to be removed and retrofit before we could actually put up the antennas. Again, other pictures of the antennas on the range. The way they test these is they actually generate a signal from another antenna, and they use these as receive antennas set in the field exactly within the aperture, and this rotates on this base 360 degrees so they can see what the antenna is receiving, and that correlates to what it would be transmitting. So they did that with the upper U, the V, and then later on the lower UHF antenna. We then got the whole team together. The guys from IAT, the guys from RFS, the guys from the electrical concern who put it together, and the structural engineer, and we all went over all the drawings so everybody would know how this went together at the factory so we could reassemble it here. Here's some of the fittings before they're coated with the gray paint that they used to put outside. And there's part of the motley crew that actually put this project together. And at RFS, whenever anybody goes over to the plant, they do a picture on the staircase, so there's their official photograph of the group. RFS also manufactured the combiners. So there are 2 combiners for UHF, plus 45 and minus 45 feeding one antenna, and the same feeding the other antenna. They are absolutely identical, except that this one has 8-inch outputs, and the other one goes from an 8 to a 7-inch output to the other lines. Other than that, parts are totally interchangeable. They're mirror images of each other. And that's what it looks like through the mask filter, the 6 megahertz sharp cutoffs on it, so it's showing that any technical people, that is absolutely on channel, nothing extraneous going beyond what's allocated for any specific station. And we even had time for golf in Abu Dhabi on the way over. And that's the whole team at RFS that put it together, and a few of us other hangers-on who came from the States to do the testing. So, now moving back to here. As I said earlier, all these pegs were up there. They all had to be removed to put the antennas up. RFS designed adapter plates to go into the mounting holes that were originally put in the spire to put those antenna panels on by utilizing what was already in place. The antenna panels just snugged right onto there. Some of the first panels going up, and here you can see them being built. As I said, they went up like that, about 4 at a time, and then they were put in one at a time. The connectors put on each one of them. That's as we're getting close to the end. You can see part of that catwalk or crow's nest still being there. They needed it. They used it for hoisting. And this is the view inside. We put a set of climbing pegs also inside the tower. For those of you who aren't familiar with towers, those pegs are about that wide, enough to put your foot on, and that's it. And there's a view with the cable looking down from the ladder. All the cables were color-coded, so they knew exactly which one went where. They matched antenna to cable, so everything matched what was done at the factory. Cable management inside, they actually made some blocks so these lines actually go in, and you could stack them 4 across as deep as you wanted to go just by changing the threaded rods, or you could go out wider and put them in that way. So that's all interlaced up inside that way. And here's the antenna, the top antenna with the interstitial radomes between the panels, which acts to make it a one panel for the wind loading. Again, sections going up, and this is the power divider you saw in pieces from the plant. Here's the guys actually putting it in place. The other one is on the other face. This is feeding the top antenna, and there's another set lower down to feed the bottom antenna on opposite faces, and the VHF are on the faces opposite that. So if you look up at the building and you see funny looking things hanging there, you really can't see them from the street, but that is about 20 feet long. This is a 40-foot section. And there's your typical wow shot from the top. Looking down through the grating, the transmission line going up. Down here, it's all copper. Up here, it's copper. It's been solar coated. Each antenna, the UHFs, there's two lines going up. We have to keep them in phase. By solar coating them, we don't have any effect from the solar radiation from the sun, so the thermal effect is minimized. We actually did a test of 2 lines from pre-sunrise to post-sunset. So we had the cold air, the sun going up and going down, and the solar coating kept the phase between the 2 lines of less than a degree off over the course of the whole day. So the solar coat is definitely effective to control any thermal effects of the sun on the lines. And there's just another couple of views looking down from the perspective of the guys up there working. On the rings, we have ENG antennas, STL antennas. These happen to be WNJUs from this station. They have 3 of these placed 120 degrees apart. NBC has 3 of them placed 120 degrees apart, 45 degrees off of these. Two-way radio, GPS, studio transmitter links are on the next ring down, and the bottom ring we were originally not using for anything because that was the escape route for the window washers. We're changing out the window washing rig, so now that whole third ring is now open to me to populate. GPS lower on this slide. Rather than have everybody put GPS antennas up, we actually have 4 GPS antennas on the 4 cardinal points, northeast, south, and west, feeding down to a room on the 104th floor, where we have a distribution system to feed GPS to anybody who needs it coming off of those antennas. They just plug in, pick it up GPS as RF. They can plug in and pick it up as fiber. We also have a rubidium backup, so we're generating 10 megahertz clock up there. So if we lose a GPS signal, we still have clock being generated. And Chris, through DSI, has put in the fiber between there and here. They did the GPS system distribution system, and we actually brought it down. We have 6 bundles of 72 strands of fiber connecting 104 to 90. That's internal to the building that other tenants and others have no access to, so they can run every broadcast that has glass running back and forth. They can use that for whatever facilities they need to get from the rings to this floor. These are just some views of the east face, under construction, the west face, north and south.
It takes quite an amazing person with amazing qualifications and caring and intelligence and great personal skills too, to be able to oversee a project like that and even come in and make changes to some of the original designs so it actually works well. You are watching or listening to This Week in Radio Tech. I'm Kirk Harnack. Chris Tobin is along, and we are right now watching and listening to John Lyons. John Lyons, who departed this world about a month ago, just after Thanksgiving. And he's well remembered by engineers and other people in our trades. We're going to take a quick break and hear from the folks at Vox Pro and Broadcasters General Store. We'll continue with John Lyons' presentation in just a minute.
Yo, what's up? Live from NAB 2018. Hey, it's Caden. You need to check out Wheatstone and Vox Pro 7.1. The upgrades are amazing. If you're a jock, if you're a talent, producer, whatever, morning show, everyone knows Vox Pro, everyone uses Vox Pro, everyone loves Vox Pro. But now the features for this year, 2018, on 7.1 are amazing. If you're using version 4.5.6 and you go to 7, this is exactly what you're missing right here. The features are a game changer. It's going to cut down your editing time by like 80% depending on what you use Vox Pro for. And with version 7.1, introducing unlimited Practic button bars right here, hotkeys right here. I'm gonna show you coming out of a song.
Bad things, it's a lot of bad things that they wish and I wish and I wish and I wish.
So you're coming out of your song?
Yeah.
Start your next song right here. It's basically an entire production room right on Vox Pro. So it's the Vox Pro we know and love with a ton more features. And now, this is the ultimate game changer right here. Effect macros. So instead of hitting your effects button bar and going up here using your mouse for every effect, you do it right here with one click of the mouse, and you're gonna cut down your editing time by about 80% without even touching this new sexy black controller. Check it out right here, Wheatstone Vox Pro 7.1 at NAB in Vegas 2018.
Vox Pro is available at Broadcasters General Store, and you can contact them. Give them a call at 352-622-7700 or on the web at bgs.cc. bgs.cc, awesome people, and I appreciate them and Vox Pro for sponsoring This Week in Radio Tech. It's Kirk Harnack along with Chris Tobin. We're going to head right back into John Lyons' presentation that was given next to a transmitter in the new One World Trade Center facility just a couple of years ago. And let's hear the rest of that, and then Chris is going to have some good remembrance of John Lyons at the end of our show. Here we go.
The Durst organization, who I work for, co-owns the building with the Port Authority. It's a joint venture. We are a very green company. 4 Times Square was the first building that actually set the gold LED LEED standard. Before LEED became an object, that was a building that kind of got it started. One Bryant Park, our main office, is the first commercial office tower that's platinum certified. So it's a family tradition, family heritage. We also have an organic farm upstate New York. All of the tenants who have cafeterias subscribe to that. All their compost and waste goes to the farm. We also buy recycled paper and all that. And again, the tenants have all bought into that philosophy. Part of that effort was to bring the power up here in a useful, non-wasteful method. So everything being 480, we didn't bring 480 up from the street. We brought it up at 13.8 kilovolts. And we're actually converting it to 480 on the floor. So that's a 13.8 feed. There's two of those. Primary and a backup feed coming up the building. That's the feed. If we did it at 480, we'd have 20 of those in each riser closet to get the same power up here. We put the dual-ended substation up here. Those are the transformers as they're being built. The floor is all EMF protected, so we don't have 60 hertz running all over the place coming out of there. That's the room across the hall. I cannot show you that because it is 13.8 kilovolts, and the Port Authority has everybody who does not need to be in there locked out. Much better safe than sorry. That's the door across the hall. I'm going to go around some of the other facilities being green. This is what you're looking at behind here. These are the pumps from the combiner, which is on the other side of the floor. And Gates has slightly different pumps in the CBS area over here. But essentially, they're the same. They're pumping glycol water mix. They're doing 39% glycol, 61% water. They're doing 50-50. Different philosophies in the two different companies, but essentially it's a glycol loop to help with the cooling. Transmitters are all water cooled up here. We exhaust the heat through brazed plate heat exchangers here on the floor that go up to the 103rd floor where they hit another set of plate exchangers that go up to the cooling towers. So primary loop is an open water loop that exhausts the heat into the air, goes to the 103rd floor, which is in a closed loop from 103 to here, and then we go to the heat exchangers with the broadcasters to then go from the plate exchanges to the transmitter and the pumps. The only area that is glycol is down here on the floor. Just some of the pumps as they were being set up. What we also did above the top, you'll see some green flashing lights if you look up above the transmitters on the active ones. We have energy valves on it. These modulate the water. We keep the delta from inlet to outlet temperature of 10 degrees so that we're not wasting water up on top. We're supplying what's needed, no more, no less. And also the pumps, both the ones that I just showed you and these pumps are modulating pumps. So if we're at, say, 9.5 degrees and they really want 10 degrees, these will ramp up a little bit to get that 10-degree delta. So we're really being energy efficient with the use of the water in the building. This is what's behind you as they were building it. This is WNJU. Before they went on the air, they were still building at that time. As I said, this transmitter is on the air. It's been on the air since June 23rd. It's running to the top antenna, which is live at 67 kilowatts. When they move to their main antenna, which is the bottom one, when it's finished later this year, it'll be running, I believe, licensed power is 97 kilowatts. Richard on CBS is going to be running about 80 kilowatts, I think, licensed power, transmitter power. It's not effective radiator power. And again, being water cooled, the noise level is going to be like this. For those of you in broadcasting, especially those from years ago, we could not be having this conversation now in this environment because the noise would be worse than a jackhammer by about 20 degrees of the noise coming out of the transmitter from the air-cooled transmitters. Water cooled has definitely made a considerable difference to both everybody's hearing and work environment. This was, as we were testing this transmitter, they were running at that point 65.46 kilowatts, 99% power. And this is just a screen of the control in there. This is the VHF combiner and the 4 transmission lines that go through the wall and upstairs for the VHF, because they all have to be phased the same, so the signal goes out all 4 antenna arrays at the same time. You have trombone sections of varying lengths to make that phase be. By the time it hits this wall, they are all absolutely at the same part of the cycle. Again, different shots of the energy valves in the other location over there. Being green, all the transmission lines came from IAT across the river in New Jersey. It's about 30 miles away. They ship all their line in boxes. Well, I didn't want boxes being manufactured 30 miles away and brought here and discarded, whether they went into a landfill or they were recycled. So we did a program with them that the truck came in with the lines, the next truck that brought the next load in brought the empty boxes back, and we recycled the boxes until they were really unusable to go, and then they were discarded, and we do have a recycling place, picked them up. They didn't go to a landfill, as cardboard was recycled. I talked about the solar coating in the spire. This is a shot later on when all 8 lines were in, all the springs were then tensioned. For those of you not in the broadcasting arena, copper, 300 feet, 400 feet of copper moves about plus or minus 1.5 inches, depending on summer or winter in the city of New York. So everything is on springs. They're fixed hangers, top and bottom, springs in the middle. The springs are tensioned to the temperature in the environment the day they're put in. So if it's 65 degrees, the spring may be tensioned 15 inches. If it's 85 degrees, the spring may be tensioned 12 inches. The tension on the day they were put in, so overall, depending on whatever the temperature is, the springs are tensioned properly, and they'll all move together, because the last thing you want is things to be splitting, O-rings to be opening up, or whatever. So, being the World Trade Center, security issues, and everything else, trucking, logistics was very important. As I said before, the antennas came from Australia, the combiners came from Australia. They were air-shipped, which meant they had to be laid horizontal to fit in the cargo hold of an aircraft. Coming into the building, you came up in one of the elevators. They're vertical, they're not horizontal. Everything went out to Myatt, was restaged. Some of the stuff was left the way it was and just stood up. Others couldn't be. The plant in Australia actually took all this into consideration, and they told them, okay, you remove this board, this board, this board, you have to stand it this way, you can't stand it that way, just to deal with the logistics, which was a nightmare. Shipping, security, and everything else. The trucks, anything coming into this building, the drivers have to be identified in advance, and the VIN numbers of the vehicles have to be in the system. If they don't match, you don't get in. That's simple. Broadcasters will have a trusted worker program so that they'll be identified. They'll all be security worker access scanned ahead of time so we know who they are. All the secure areas are biometric readers and swipe cards. You need both. So if somebody cuts off the finger that's in the scan, you're not getting in. Everything was 3D rendered, the whole job, so that we can make sure, as you can see, I've got 23 vertical feet above me, well, 17 above me. Everything had to be in proper layers so that everything could pass each other. So the water is all at the same height. The electric feeds, including the 13.8, which is identified, are at the same height. All the transmission line going across the floor will be at the same height. All the duct work. Again, everything had to be layered in to make sure it would all work. Unfortunately, having a 23-foot ceiling in here was able to function. If it was a normal height ceiling, doing this would be an absolutely impossible task. So we had an architectural firm do all the 3D modeling. You can actually see in this shot, there was a hit right here. We had this water pipe hitting this line. We had this pipe smacking into that line. That's why everything was done in color, so they could see where the hits were and do all the adjustment. And that definitely helped in the hallway, because we have input lines from the transmitters to the combiner in some cases, and output lines in going back into the hallway and into the shaft to go upstairs. So there's a modeling of that. The upper lines are the two lines you actually see over Kirk's head there. 2 other lines in the wall there going to the combiner down the hallway, and the 8 lines coming from the combiners going back in the hallway to the shaft. And the next shot, I had to turn it 90 degrees to fit it in, but remember what you're seeing here, and there it is in reality. So, just to make everything fit, and also to make sure, for those of you in broadcasting who have worked in tight spaces or in the original Trade Center, as Harold can attest to, lines were put in smack together right next to each other. If you had the line in the rear that had to get out, everything in front of it had to go. We made sure there's spacing to remove every single piece without affecting the adjacent hardware to it. This is the 7-inch line going up to the upper antenna. This is the standing wave ratio. 1.2 to 1 is acceptable, kind of in the outside. Nothing here is worse than a 1.1, and that's only a couple of places. And this is actually the band that's going away when the repack takes place. Everybody's moving down to below 600 megahertz. So these little components that are actually here at just about a 1.1 will go away, and we only have a hit of 1.08 VISWAR here, which is spectacular. Transmission line in itself is a 103, can't be lower than that for this size line. So the fact that the entire system going up to the antenna is that proves that everybody did their job and did it right. That's the one line of the 7-inch, and there's the other one. So you can see they're both very, very close. Again, the outer band components over here. Logistics. Elevators were measured. Crating had to be done properly to get it in the building. They actually took these antennas for the lower UHF antenna. We wanted them put up in 3x2s, otherwise it would have been 96 picks. Doing it this way, we had 16. It was still 16 times we had to hoist equipment up. So they actually made a mock-up of this and fit it through the corridors and the walkways and into the elevator to make sure they could actually get it on the roof and under the diagonal steel to get it up there. A lot of logistics went into making this work. Crates were marked, sized, right side up, truth tables to show whether or not it had been tipped wrong. This is by the combiner section. Again, we're just dealing with RFS. I wanted the broadcasters to be able to get their own forward and reflected powers off the equipment, not being generated by me, where somebody could say, well, you fudge the numbers. They've got a home run raw feed right off a forward and reflected port, right at a combiner. Each station has their own pair. They take their own feed. The cable's running on the ladder rack. The black cable over my head going in there is their feed from those combiners to their equipment going back to their studio. So I have no control over it. They're seeing exactly what the system is putting out without it going through anybody else changing it, critiquing it, adjusting it. Up on the tower, we were fortunate to have Todd Loney here doing a lot of the testing for us for RFS, and they also were hired by WNJU to do their system testing. This is at the antenna input on the tower going into the antenna. Again, standing wave across the entire UHF spectrum is the highest point of 1.08. That's antenna only. Input to the combiner, that's what it looks like. Again, the upper part of the band is going to be gone. The actual part of the repack band, the highest feed there is a 1.08 across the entire system. This is one of the antennas. When they got it onto the roof, you can see they had to put wheels under it, change the packing, use the hoist to get this stuff under. That diagonal beam we could not remove. They had to get past that with everything. The elevator is about where I'm standing. So everything was based on that diagonal brace to get it past there. And that's what it looks like. Originally they were planning on trying to pick a face at a time. The whole 32, or the whole 8 times 2, 16 panels at a time, but they decided that it was too much wind load and it was easier to pick them up and mount them up get the mounts up and just attach them. So it was more picks, but more efficient. My project manager from Tishman, Pat Keating, Elite certified Marine, worked in Desert Shield, Desert Storm, did construction over in Iraq. Jim Graff, a lot of you know, master rigger, old timer. I've been doing this for a long time. I brought him out of retirement to finish this job, which he fights me on every day, but he's still here working. And there's Pat on the spire. Pat did a lot of the pictures up on top. I think he's past his 51st climb now. He never climbed before, went to climbing school, full protection, all the training, and he's my eyes in the sky.
That is John Lyons making a presentation about 2 years ago. John Lyons, who passed away this past November 28th, beloved by engineers and all kinds of people in media in the New York City area. Chris Tobin is with us. Chris, we're going to take a quick break, our final one, and we're going to come back with your thoughts about John Lyons and what we can learn from John, what you learned from John, and how John was such a leader in the business that we're in. We'll be right back in just a minute after this from CalRec.
CalRec's Type R is a modular, expandable IP-based radio system featuring 3 slimline panels, a fader panel, a large soft panel, and a small soft panel easily configured to give the operator full control. Layouts are saved and recalled quickly between shows. A single 2RU core with integrated I/O gets customers up and running fast, and that single core can power up to 3 independent mixing environments with no sharing of DSP resources. Available in 4 DSP packs, and as your station grows, larger packs can be added, enabling it to grow with you. Power to the surface is supplied via standard PoE switches, keeping cabling to a minimum. Type R is fully AES 67 compatible, as defined by SMPTE 2110, which means that it is also compliant with NMOS discovery and connection management specs. All these features combined make Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
Thanks a lot, CalRec, for sponsoring This Week in Radio Tech. If you go to calrec.com/TWiRT, they'll know that we sent you. Thanks a lot. You know, the people at Angry Audio, that's Mike Dosh and his team there at Angry Audio. They have put together an amazing business just for us broadcasters. Sometimes you need a little help. You need a little device that's going to do something for you. And there's a whole range of Angry Audio gadgets and gizmos that you'll find right online on their website, angryaudio.com. And this is one of the devices. And I want to point out that Angry Audio gear is designed by some of the same people who designed gear at PR&E, Pacific Recorders and Engineering. PR&E is well known for their fantastic gear. Angry Audio is becoming well known as well. High performance audio gear, just little things you need. This is an audio distribution amp. It's a stereo in, of course, and it has either IHF minus 10 dB or professional plus 4 dB inputs on XLRs. And then it has lots of outputs available right here on, some people call this a Tascam breakout cable. It actually has a standard number, but you can get the breakout cables for this to bring it out to XLR, bare wires, whatever you like. And then on the front here is where you have your controls for mono stereo on each of the channels. This is super high quality. It's also a little bit heavy. Why? Because it has a real power supply in it. Yeah, a real, actual, traditional power supply with a power cord, transformer, and everything. This is the real deal. And all of the gear from Angry Audio is designed this way. You want to know more? Easy. Go to their website at angryaudio.com and see which devices turn you on, which devices you're going to look at and go, oh, I need that. Oh, I need that. Oh, I need that. Scroll down a little bit and we'll see the new Bluetooth gadget. There's just so many of these things. Great sound, problem solvers, built for broadcast. Here's the Bluetooth gadget, the distribution gadget, the one that I was holding, the bi-directional balancing gadget, and there is no other balancing level change gadget that is designed as well as this one is. It's really, really good. You talk about clean audio, you get it with Angry Audio. Go to the website, check them out. angryaudio.com. Their gear is available through most broadcast dealers. So ask your broadcast dealer for Angry Audio gear. Thanks so much, Angry Audio, for sponsoring This Week in Radio Tech. All right, we're about to finish up our program, and Chris Tobin had the pleasure of working a number of times, quite a few times, with John Lyons. Chris, you were there at the seminar that we just saw, the presentation, but you also worked with John Lyons and lots of times that we don't know about. What are your thoughts?
John, I can say I was a mentor. I knew John for 27 years, I guess it was. He was the kind of person that, old school. I'll use the phrase old school. You know, it was a handshake and the deal was made. If there was paperwork involved, they should take care of it, but the handshake is what mattered. And he was all about learning. He would read up on anything and everything. If we were somewhere and say at NAB and we're walking past a booth of some new technology, if you will, he would look at it and go, what is that? And he goes, I'm not sure yet. And by the end of the week, he'll know exactly what it's about and how he could apply it if need be. So he was always about looking out for the next thing, keeping ahead, staying on top. I mean, at 71 years old, the guy is working at the rooftop of World Trade Center and putting together technologies that most people are like, well, that's nice, but I'm not sure. He already had planned that out 15 years ago. It wasn't happening in that video. It didn't happen that week or the week before. He worked on that way back. And, as Tom pointed out, 4 Times Square originally looked one way. And then he realized, we could do something else. And now it is what it is today. So, he looked way into the future and realized the potential of stuff. He also is proud of saying that the TV folks at One World Trade Center, when ATSC 3.0 comes online, the antenna system or the transmission system is already worked out so that it can handle the higher power and any changes that have to be made. That was built into the system 10 years ago. So yeah, he was. It's difficult to say. When I was at the burial, it was a Air Force honor guard. They blew taps. A lot of folks were there. It was weird. It was just weird because it was like, wow, I only talked to him. I literally was with him on Monday of that week. Many of
Yeah.
us were. There's several of us that were with him that week, and all say, hey, have a good Thanksgiving. Be well. We'll see you all next week. We have some projects on Monday of that following week, and that's it. And that was it. I mean, it was interesting. I mean, when I got the call that Friday, I was like, what? And yeah, it's still sometimes I walk past, I look along the skyline, and it's the first thing I think of.
We one other person that knew John Lyons, and he knew so many people, but knew him well, was David Bialik. David did the quick introduction of John Lyons in that seminar that we saw. David Bialik just commented that John Lyons changed the RF landscape of the #1 market in the USA, and he was a nice guy too. That's a real quality when you get somebody who is that visionary. And a lot of times people who are visionary and work to make things happen, they're not always the nicest people in the world. They're very focused on their job or the impact they want to make. The fact that they've got to wrangle a lot of different people to do things in order to get a job accomplished. And John Lyons had this amazing quality that I wish, more people, including myself, had, which is to be a really nice person while you're getting things done.
Yeah, no, John was definitely that. I mean, as Tom pointed out with the key card, I can tell you that on many projects, on many occasions, John would call me up and say, I need a favor. Can you help me out? I'm like, yeah, sure, no problem. Never expecting anything in return. I knew that somewhere down the road, if I needed something, he'd return the favor. And that's how it worked. He took care of people that knew what they were doing, and they treated him like he expected, and he treats them the same way. So David is spot on. He was definitely a very nice person and definitely focused and definitely knew what he wanted. And if you didn't get it, you probably didn't like what he would say to you because that's just the way he was. But he, never a bad thing. It was always straightforward. And trust me, as Tom pointed out, I'm glad to see they hired the same barber for the engineers at WOR. That was John. If he didn't like the way you were doing something, he didn't sugarcoat it. He just told you straight out. And then he'd say, let's go to lunch.
Chris, I'm glad we had this time to remember John Lyons, as I know a lot of people will be doing for a long time to come.
Yeah.
Yeah. Listen, it's almost the end of the year. I don't know if we're going to do a show next week or not. I kind of want to. I just want to get together with you and maybe a guest and dish for an hour.
Sure.
It might be a nice break from the holiday hubbub. So I tentatively let's plan on it, but we'll see what happens and I'll be in touch. I want to thank you, our listeners and viewers, for making This Week in Radio Tech the popular program that it is. Chris and I, wherever we go, and sometimes we show up together, hang around at different trade shows. That's about the only time we get to see each other. We get people walking up to us all the time saying, hey, thanks for the show. Thanks for This Week in Radio Tech. By the way, if anything we say about our sponsors interests you at all, please let them know that you watch the show. It is very helpful to us. It does cost money to produce the show, and we appreciate your help in doing it with sponsors. So thanks a lot for that. Thanks to Suncast for producing today's show. Oh, and I shan't forget Tom Ray. Thanks, Tom Ray, for being on the show and for making a quick guest appearance for us. Would love to have you back again. It doesn't always work out with your schedule, but Tom Ray is just terrific when he makes a guest appearance here. Chris, we got to go. Thanks also to Andrew Zarian for founding this network and it being here so we can do our webcast, the GFQ network, where you'll find lots of other interesting podcasts. Yeah, interesting, I said. We're going to go. We'll see you next week on This Week in Radio Tech. Bye-bye.